Hi, John Valvano here. In this video, I'd like to give you a brief introduction to how to do the extra credit option 1 part of Lab 6. And so the idea here is to create software that can play music. And so before we get into the code, we got to understand what is involved in music. And so there are two aspects of music, which is a sequence of notes. The first is the duration, or how long each note is, and the second is the frequency, or pitch. Okay, and so if I look at my my sheet music, I can divide the notes in time this way. Now it's not to scale. That's okay. We'll put the scale in a moment. Okay, and I won't do the whole song. I'll just do a few. And so in cut time, this is cut time, a quarter note is going to be 250 milliseconds. A half note, 500. Another half note, 500, 500. This is a rest, but it's 250 milliseconds long, and then we have another quarter note there. And then I'm going to encode in my software these durations with a special code, and the Q will mean 250 milliseconds, and H will mean 500. H. No, that's not an H. That's a Q. Q. All right. The second aspect was the frequency, or pitch. And we saw in the regular lab that's essentially going to be encoded or defined as reload values for my SysTick to generate that pitch. But when I see this in time, this quarter note here will have a very low frequency. That's a very low A. And so we're going to see, if we looked on the oscilloscope, a very low frequency associated with that A. And this D is a little bit faster. Okay, so it'll have a little bit faster. And now we got a second D, which will have the same frequency as the other D. But this one is a F sharp, and it's got a higher frequency than a D, and so it'll be a faster one. And so we see three different frequencies here, and the rest will be a straight line, and then we'll have another slow one. Okay? I'm going to encode the frequencies, again, as defined constants, which have reload values in it. And I'll call this one A0, because that's a low A. And this one is a D, and this one is a D, and this one is an F sharp. There's a sharp there. And this is a quiet, or rest, and I'm going to give it the code Q, and then we have another low A. Okay? All right. But there's a problem associated with that right in here. Okay? And that is, because this is a continuous waveform, these two half notes here are going to look like one whole note, not two separate notes. So in order to make it sound right, I am going to put in a little bit of pause, a little bit of rest right here, a little bit of rest, such that right here it doesn't change. And I'm going to make it really small, and I'm going to call it, I'm going to give it a I don't know, 25 millisecond wave. I'm going to steal it out of here. So that'll be 475, and I'm going to give it the letter G, or gap, so that I can hear these two half notes separated here by this 25 millisecond gap. All right, because I remember the gap. All right, so now let's translate this sheet music into code. Now, if you want to learn more about sheet music, take some other class, but we're learning embedded systems. All right, this is my sort of rough sketch of my Lab 6, and I'm going to introduce the steps for the extra credit. The first thing I did was create two files, music.c and music.h. And then over here, I added music.c. I added that to the project. All right. Because music is going to be built on top of sound, I'm going to include it. Okay, so now remember, the music that I created was a sequence of notes, and each note was a combination of pitch and duration. Okay, so A0 is the pitch, D was a pitch, and again, it was a half note with a gap stolen out of it. And there's my gap right there, a quiet of 25 milliseconds long. And there's my second D, and there's my F sharp, and there's my rest, and there's my A0. So those were the 1, 2, 3, 4, 5, 6 notes with a gap in it that we had in the previous slide. Okay. Now what I'm going to do is have this null terminated. Now it's not my entire music, but I'm going to null terminate it with a 0. Okay, such that a pitch or a duration of 0 means I'm end of the song. Okay, all right. Now we have to do is figure out how all this works. And so I'm going to use a timer, a 32-bit timer. It's like Systtic, a little more complicated, but 32 bits long. Just like Systtic, it counts down at 80 megahertz. But since it's 32 bits, the longest duration I'll be able to create is 53 seconds. Plenty long enough for my half notes or whole notes or whatever I need. Okay, so I'm going to create some defines. Again, each quarter note is 250 milliseconds, and at 80 megahertz, the number of bus clocks in a 250 milliseconds will be 80 million divided by 4, or 20 million. So the little q here is going to be 20 million bus clocks. All right. And so then I'll have my half note, which is twice a quarter note. If I had any whole notes, they would be 4 times. Remember, my gap was 250, or 1/10 of a quarter note. And so now I have to think about how I'm going to combine these 3 things together. And so I'm going to need a pitch, which is reload values, and a duration, which is going to be the number of timer zeros to wait. All right. And so I'll introduce a pitch and a duration for my device. I'll create a type def, and I want to put it in ROM, and I'll call it note T. Okay. So now I'm going to create my song, which is going to be Deep in the Heart of Texas. Okay. So I've got 8 entries, 7 notes, and the null terminator. And so that is it. And I've just created my music. So my music is going to look just like my sheet music, a sequence of pitches and durations. All right, I got to create a couple of functions, one to initialize it. So again, I'm in the H file. So these are prototypes. How am I going to play a song? I'm going to pass in a pointer to whatever song I want to play, which will be a sequence of notes. All right, that's my H file. Now let's look at what I got to do for my music file. Okay, so again, the music.c is the implementation. And so there is a timer 0A that I'm going to initialize. There's a couple of examples. If you want to see how it works and run it separately, you can open up the periodic timer example and run it separate from this. But I'm going to initialize it. Basically, I turn on its clock. I set it up in periodic timer mode. The interesting parameter here is this thing called tail R. Tail R is the reload value. Again, a 32-bit value, which will determine how long until the next interrupt. Okay. There is an interrupt service routine, a second interrupt service routine, and this is going to get invoked every time I every time I want to change the note. And this line here, this ICR line, will acknowledge or clear the interrupt flag. Okay, here are the rest of the details. We're going to set its priorities. We're going to arm it. We're going to enable it, and we're going to turn it on. And at that point, this interrupt is ready to roll. All right. Inside the timer interrupt, again, this is going to get invoked on every note. Okay, and I'm going to want to shut it off. And so I'm going to disarm the timer and quit the ISR under 2 possible conditions. One is if my pointer is null, and you'll see I'll have a pointer which points to my music. If it doesn't exist, I'm gonna quit. My other condition is if the song is at the end. Again, a duration of 0 means that's the end. That's the null terminator of my song situation. Okay. Otherwise, what I'm going to do is get a new pitch out of my data structure and call sound play. And then how long am I going to play that note? I'm going to get the duration out of the device, out of the structure as well. Set that to tail R, and that will determine when the next interrupt will occur. All right, I got to increment my song pointer so that it will run on the next one. One more. Okay, no, I got more. I got to do my, like I said, I do have a song pointer that points to the song I'm playing. And in my initialization, I got to initialize the timer. I got to initialize the timer to not be running. So during initialization, it doesn't run. And so if you set IMR to 0, this timer will be disarmed. All right. And obviously I'm going to set my song pointer to null so that, on initialization, it's not playing songs. All right. And then I have a play. And again, play is going to take a pointer to a list of notes. That's a song. And what I'm going to do is initialize my song pointer to point to that song and then arm the device. So again, if I write a 1 to the IMR register, that will arm the device. All right. Yeah. Okay. So one more, and that is inside of my main program, I got to link this high-level program to the song, to the music. And so I do that by including the header file. Somewhere down here, I have to initialize it before I get going. And then if I want to play a song, right? If I want to play a song, I call music play and I pass in the song I want to play. So in summary, that's kind of the way it works. I left out a lot of details. That's why it's extra credit for you to get all this to fit together. It's a little bit tricky to have 2 interrupts running, but that's why we give you extra credit. So enjoy it. It'll be kind of fun. Try to make your TA dance, okay? All right.